Right, this is AQA SS1B June 15 question 3. Okay, so this is 14 candidates, that 2 papers each, paper 1 and paper 2 on the same day. So same candidate, same day. The marks are a total out of 50 and achieved by the students on the table, and it's shown on the table. So this is 3 marks for working out the product moment correlation coefficient, which is one of the nicest things to do on the calculator. So the first thing you do is sub in all the information that you have from the candidates. So list 1 is going to be X, as they've shown, and list 2 is Y, which, as I showed you when we did calc and setup, that's what we have. X goes here, here on your 2 variables, Y is in the second one. So that's good. Then it says calculate your product moment correlation coefficient R. Well, R is associated to the regression line in a way. It is the correlation, it's how correlated the data is, and in your GCSE you would have drawn a line of best fit, which is your regression line. So there is a button on here, which as you can see is regression, that is connected to our product moment correlation coefficient. So as long as our setup was right with those 2 variables, we press that, press X. You may have the choice of A plus bx or b plus or a plus xb, doesn't matter really, as long as you write the equation down properly if you're doing a regression line. In this case it doesn't matter which one you choose, because we're only interested in the product moment correlation coefficient R. Now the calculator gives you R and R squared. R squared and MSE, the mean squared of the errors, this one, and R squared are 2 values that we don't need. Ignore them. We only want A, B or R, and when we're looking at the correlation coefficient we're looking at R. So all we have to do is manage to write that down if I can remember it. So our product moment correlation, I'm going to write it up here because I think I'm going to need space somewhere else, is 0.7480182. Don't write it up here in the real exam, obviously, write it down in the space provided for your answer. It then says interpret this value in context of this question. So there are some templates that you can use for these types of things, but the easiest one for this one then is first of all, like your GCSE, you have to say what type of correlation. So it is a positive correlation, but on top of that you have to say how strong you think it is. So this is there is a moderately strong correlation between, and this is where you get the next mark in context, between moderately strong positive correlation between the mark on paper 1 and the mark on paper 2. If you weren't sure, or you just want to cover your belts as it was, or cover everything, you can say as the mark on paper 1 increases, so does the mark on paper 2. That would be belt and braces. You've got absolutely everything there, so you would have done both of those. Okay, brilliant. Next. It was discovered that 7 of the candidates in Group T had been given extra tuition in preparation for the results, for the tests, whereas the other 7 candidates, Group U, had only been given the usual tuition. Group T has this R, and Group U hasn't got the R calculated. So calculate the value of R. So you have to go to your formula book to find this, and you will be given R equals S of xy over the square root of S of xx times S of y. So you just got to sub in the values you've been given. Okay, So I'm going to change this. So that equals 34.54 divided by the square root of, if you've got your new GCSE calculators, this is when to use them, 112.86, and that equals 0.1946. Okay, that's the answer we're looking for. Good. Interpret in the context of the question the value of R for each of your groups of candidates. And they are asking each. So don't try and mush them together. Just take a little bit of time. It's 2 minutes, because it's 2 marks, it's 2 minutes. So the first thing you would say is that this is very weak. So, and I would write group T, if I delete some of the work at the bottom. Okay, so if I can get rid of this. Okay, so for T, oh dear, for T, there is a weak positive correlation between marks on paper 1 and paper 2 and marks on paper 2. Okay. And then you would say pretty much exactly the same thing for group G. Okay, there is and in fact it's even more so, so there is a very weak correlation between. Okay, that will definitely cover everything, and that's what you want to do. The next bit was the really sneaky bit. So comment with justification on the apparent effect of the extra tuition. Now, the correlation coefficient doesn't tell you which is better. It tells you which is correlated better. But they're both positively correlated. There's not very good. But the extra bit of information that you have had that you haven't used yet is this. And that's what you've got to use. So they are correlated. There's a definite correlation between the two papers. So if you get a good mark on paper 1, you're going to get a similarly good mark on paper 2. There is a correlation between them. As one goes up, so does the other, is all that's saying. But where we're confirming in 3, or III, or comment, is that we need to say that group T, the one that's had the tuition, has a much higher mean value than group U without the tuition on both papers. Okay, so that is, that's the sentence we're looking for. The mean of X on paper 1 is higher in group T than it is in group U, and the mean of Y is higher in group T than it is in group U, which basically gives you the conclusion that the extra tuition seems to lead to better performance on both papers. Okay, that is what you're looking for. And that's it.